Okay, review part 4, the conclusion on this Yak54 3D plane. Let me give you some numbers first. My all-up weight with the GNB 3S 550 milliamp hour ADC LiPo was 288.8 grams. My power system puts out 563 grams of thrust, which comes out to 1.95 to 1 thrust to weight ratio. Okay, the plug and fly cost of this build, and I use budget components. The plug and fly build does not include the receiver or the battery, and it came out to $67.06, and that includes the glue and the tape and everything that I used. So I think the way this thing flies, and as fun as this plane is to fly, and the way it handles and how graceful it is in the air and how maneuverable it is, I think, yeah, it's definitely worth $67.06 for a plug and fly build, but you guys will have to be the judge of that. The servos, I used 3 9-gram servos. They were all old EXI servos that I had. I was going to use a 9-gram servo and 2 5s if I could get the thrust that I needed out of a 2-cell. I wasn't able to do that doing my bench testing with the power system, so I decided to go with 3 9-gram servos, and I would recommend that for a 3S setup. I will have a list of links in the show notes to components, budget components, that you can use to build this plane. Some of the components are precisely what I used in my build. I did not use the servos that I have listed, which are Racer Star SG90 9-gram servos, because I had some old EXIs on hand, so I used those. Otherwise, I would have used the ones I have listed, or I would have used GoTech 9-gram servos if they had them in stock. Last time I checked, they were out. I don't know if they're going to get those back in. The motor that I used is the same motor that I used on the Volantex P51 Mustang. It is a Racer Star BR 2208 1400 kV motor. I did have an opportunity to test some additional props that I had not had before, and I'm glad I got this prop. The prop that I use is an APC 7x4 slow fly prop. I had never tested a slow fly prop before, but I'm very impressed with this prop on this motor. 563 grams of thrust. I think the KMP 7x4 prop that I used on this exact same motor on the 3S setup was putting out 524 grams of thrust. So that's almost 40 additional grams of thrust, 39 additional grams of thrust with this prop as opposed to the KMP 7x4. So I think that's pretty darn good. The speed controller that I use is one I already had in my inventory. I've done field testing with it before, and I did a review of it. It's HTIRC Hornet series. My power system was only pulling at full throttle on the bench, was only pulling 9.9 grams. So in a static position, so in the air, it's only going to be pulling about 7.5 amps, excuse me, 9.9 amps, not grams. It was pulling 9.9 amps in a static position on the thrust stand. So in the air, it should only be pulling about 7.5 amps. So a 12 amp speed controller is plenty for this power system. So that was the HTIRC Hornet Series 12 amp 2S to 4S speed controller with a 5 volt 2 amp BEC on it. And that's an inexpensive one. The LiPo I already discussed was a GNB 3S 550 milliamp ADC LiPo with XT30 plug. And I put an XT30 plug on my ESC. The other things besides the prop, the other prop that I tested, which was really good on thrust and efficiency, was the KMP 8040 prop, but the 7x4 was better. 7x4 slow fly was better. Okay, so tips and mods. Tape reinforcement on the rudder hinge, on the lower rudder hinge, where we had to glue that together as part of the build. I created a glue hinge, but I also put some tape on there as reinforcement on the outside of the hinge and on the inside of the hinge, I would recommend that you do that. I noticed that the wheel assembly on this plane, where it attaches to these 2mm carbon struts, it looks like the axle for the wheel is just super glued in there, and I didn't think I could trust that. So what I did was I took some of those little thin 4-inch zip ties, and I used zip ties to reinforce where that strut attaches to that wheel assembly. And as you saw out there, I didn't have any problems with the landing gear, so I would also suggest that you do that. I also cut a slot above where the battery affixes to the Velcro. I just cut a little slot in the foam and then put a strap on there. I think that's going to be a necessity. I don't think that lipo is going to stay stationary in that position if you don't put a strap across it. So I recommend doing that. On all of the linkage stops where you've got the little nut that goes on the back of it, you want to get those snug, but you don't want to create any binding in your linkage stop. So on every one of my linkage stops, I put just a tiny little drop of super glue on the back side of those nuts right there on the threads, so that these nuts would not back off. And so far that has worked out great. So I would recommend that you also do that. You don't want that coming apart in the air. All right, the CG that I am using, and I marked the bottom of my wings. If you measure from where the leading edge of the wing meets the fuselage, this horizontal plate on the fuselage, and measure 60 millimeters back, that is precisely where I have my CG, and I liked it. And when I set up my plane, when I balance my plane on the CG, I set it up so it's a completely neutral balance. You know, it doesn't, the nose doesn't go down, the tail doesn't go down, the nose doesn't go down. It stays completely stationary. That's how I like to fly my planes, with a completely neutral center of gravity balance, and that works really well for me. I know some people are very uncomfortable with a completely neutral balance. Most people, I think, probably like it just slightly nose heavy. You might want to set your CG balance just slightly nose heavy on your maiden flight, and then test out a neutral balance and see how you like that. But it does make it pivot really well when you have a neutral balance. Alright, so control surface deflection. On the ailerons, 20 millimeters both directions, 40 millimeter total movement up and down. Expo was 25, and the control linkage position on everything on the plane, for the ailerons, the elevator, the rudder, it's on the outer hole of the servo control arm and the outer hole of the control horn at the control surface. Outer hole on everything. You don't get any mechanical advantage by doing that, but you get maximum amount of movement. And since that's a pretty lightweight plane, and I'm using 9-gram servos everywhere, that shouldn't be a problem. On the elevator, control surface deflection is 30 millimeters up, 30 millimeters down, 60 millimeters total travel on the elevator. I have 55% expo in that to take the twitchiness out of it, because that's a lot of movement on the elevator. The rudder, 55 millimeters each direction, that's 110 millimeters of movement in both directions, 45% expo in that. So, and that worked out really well for me. I was very comfortable with those settings. I think that if you set your plane up like that initially for your maiden flight, I think you will have a very successful maiden flight. Okay, and on the control surface deflection, I want to show you where I'm measuring the control surface deflection. On the ailerons, right here at the very inside edge of the cutout for the aileron is where I'm measuring the control surface deflection. On the elevator, I'm measuring right here at this corner, right where the cutout angles back to make room for the rudder. That is where I'm measuring the deflection. And on the rudder, it is at the very end tip, the farthest extent of the rudder. And that's where I am measuring control surface deflection, so that when you set yours up, you know exactly where to measure to get the same amount of deflection that I have set up on mine. because it seemed to work really well. My ultimate conclusion on this plane is I highly recommend this kit. It's a pretty straightforward build. The only modification that I made on my build was reorienting the aileron servo so that it was underneath instead of on top. And I modified how the landing gear attaches to the wing plate and also reinforced the struts. And that was the only modifications that I made to the plane. And those were pretty straightforward, pretty simple modifications to make, and I'm happy with both of them. The plane flies great. It's great. It's a great slow speed 3D trainer plane. I think it's going to be a good 3D trainer plane for me. And it is just a blast to fly. It is so maneuverable, and you can fly it so slowly. And it looks completely graceful in the air. So I hope you enjoyed this review. That's my take on this plane. I really like it. I want to thank Banggood again for sending me the kit to review my very first 3D plane, and I'm just having a blast with it. So thanks for watching, and I will see you in the air.